Hi, thank you very much for joining us. This is Zero Trust Foundations in Amazon ECS with Boundary, Vault, and Consul. My name is Jeff Mitchell. I'm a principal engineer at HashiCorp working with Vault and Boundary. This is Rosemary Wong, who is a member of our incredible developer advocacy team at HashiCorp.
So if you're not familiar with HashiCorp, we'll give a short introduction. We do a lot of work in the cloud infrastructure automation space. You'll find a lot of our tools, provisioning, securing, connecting, running applications or our infrastructure. You may be familiar with some of the open source tools like Terraform, Boundary, Consul, Vault. Today we're covering about 3, and you'll see a featuring or a cameo of Terraform in here. But today we're going to be primarily talking about Boundary, Consul, and Vault. To understand the problem space that we're looking at, let's think about our data center communications. It's important to recognize that in your data center, we're restricting or blocking unauthorized traffic or access. We have a fair amount of control over that. We can trust applications and databases within the data center network. And for the most part, you can say this subnet can communicate with this one can communicate with that one. Furthermore, you can protect the secrets and sensitive information in your data center as well. So for the most part, you can manage a lot of the security of your data center with pretty fair control. But what happens when your services and your infrastructure run on-prem and on AWS? Well, the reality is that it gets a little complicated, right? You're moving from a system of record, the database or the service catalog that categorizes a service or a business unit, who runs it, how they're running it, and what servers they're running on, from the IP address to a system of engagement. We're talking about who is accessing an Amazon service, who's using this offering, who's accessing an EC2 instance. It's a very different kind of approach, and the result is that you have to change the way you think about something pretty critical, which is identity. So Jeff, what is it about identity that's so complicated?
So generally when we're talking about accessing services and accessing machines and all that, then we can break it down into a collection of kind of 2 things. There's service to service, and there's user to service interactions. And service to service is like you might have a collection of microservices that are coordinating to handle a customer request. A user to service might be something like an SRE that is trying to access some node that's not behaving properly. They want to investigate it. And we need each of those operations to be authenticated and authorized, right? So we need to have security layered in there. And traditionally, security is sort of related to things like IP addressing or kind of traditional moat and drawbridge sort of approaches to networks and so on. But in the modern era, we need to get much more granular than that. And so we need to be able to layer in notions of identity that come from things like AWS and IAM into how we are accessing and kind of managing connections between those things. So before we get into this main deep dive or demo, I'm going to explain quickly what these products are, what they do, so that they'll make sense in the context of the talk. So I'm going to start in the middle. Most people probably know Vault. A lot of people think of Vault as something like an encrypted secrets database, but it does much more than that. So it's really a pluggable security platform that handles everything from various encryption capabilities to credential generation to certificate authority. And it's all around this common core of authzen, authz, auditing that's all kind of managed by Vault centrally, and then is able to be used by plugins to Vault that we call secrets engines. And we'll get back to some of those a little bit later. And Vault can serve many needs by itself, but it is often leveraged by higher level functions. So as 2 examples, Consul is focused on the service-to-service flows by acting as a service mesh that allows you to declare what services are allowed to talk to what other services. And it can leverage Vault to act as a certificate authority to provide automatic encryption for those flows between the services talking to each other. Boundary is one of our newer products. It's focused on the user-to-service side. So it's trying to remove that traditional sort of VPN-based approach to how users access machines. As we'll see in the demo, it can leverage Vault to provide just-in-time credentials that are tied to individual network sessions. So on our agenda today, we're going to have a kind of a long demo, and we're going to walk through it, but we're going to add an identity layer for users, machines, and services that use IAM. We're going to manage credentials for IAM. After using it to authenticate, we're going to then manage credentials in IAM and Amazon RDS with Vault. We're going to secure user access to Amazon ECS and to RDS with Boundary. And then we're going to organize service-to-service access on Amazon ECS with Consul.
So what are we demonstrating today? I'm going to use a demo application that mimics an online coffee shop ordering system. Please do not order on this application. the payment system does not work and we do not want your credit card information. So it's a demo application only, but what's important is that it's a few different services, right? It's a couple of services that are running on Amazon ECS. The first is a front-end application that's running on a Fargate launch type. We also have a public API that is using GraphQL. It's a public API that, let's say, a user may need for some kind of public access or some automation. We also have an EC2 instance that is a container instance in the ECS cluster, and it's running the product API. This API is, for the most part, serving and grabbing information from a database that's in Amazon RDS. This Amazon RDS database is using a PostgreSQL type. The type is less important, but the important sequence of this application is that it is about 3 tiers, and all of the instances and services are in private subnets with the exception of a load balancer. So it's tricky to debug, right? If you're an operations team who needs to know what's happening with any of these services, you need to go through a private network, but more importantly, you want to secure all of these instances. They all have their own individual identities and their purposes. So that's a setup for today. We're going to go through a scenario where we need to deploy these applications, but more importantly, debug, operate, and access some information within these services. All right, so the first thing we're going to do is we're going to show a little bit of the setup. The first part of this demonstration is going to be creating all this infrastructure. Now, the hint is that I've already created this infrastructure because it does take some time. So I've already created this infrastructure. And one of the pieces that has already been created is Vault. I'm using a managed Vault instance today on HashiCorp Cloud Platform. It offers some Vault servers. You notice that in order to use HashiCorp Cloud Platform, you have to use a virtual network, which offers a VPC. And I've peered my VPC in my AWS account to the HashiCorp virtual network here. On the HashiCorp virtual network, I also have a Vault cluster called HashiCups. That's our demo application today. And what's important to understand about HashiCups, the Vault servers here, is that they're the servers, right? Anything that needs to connect to the servers, any kind of secrets that I retrieve, I configure, will be through here. So the important thing that we're going to configure, and the first thing we're going to do, is configure the AWS secrets engine so that Terraform can use AWS access keys and secret keys and, well, run and create some infrastructure. So the first thing that I've done is I have started with some Terraform. If you're not familiar with Terraform, that is all right. But the important part that we've configured first is that we started with the AWS secrets engine mount. So we've added a backend so that so Vault knows to create AWS access keys and secret access keys. Now, you do need an access key and a secret key from AWS to start, right? And you need it with enough permissions to either create users or create role, the role and the tokens, right? So it depends on what you're setting up. In this secrets engine setup, we're using a role. So I've already predefined a role. This is something from a security standpoint. Maybe a security team wants to audit. You don't want Terraform having permissions to everything in AWS, for example. So what I do instead is I offer kind of a least privilege approach. It only has access to RDS, ECS, et cetera. So it only has access to the services that I need. And I set a time to live as well. So I set Vault will revoke these credentials after a certain amount of time. So I will have to reissue them if I wanted to rerun Terraform again. And more importantly, we have a Vault policy. This is a policy not in AWS, but with Vault itself. You don't want everybody reading AWS credentials from Vault, right? You maybe want to restrict it to a certain service or a certain group of people, and in which case you would create a policy document that you would read at this credentials path. So what this looks like is that when you examine your Vault instance, which I'm going to print out a list of the secrets engines that are currently installed in Vault, I have a secrets engine at Terraform/AWS. Vault uses a path-based approach, so this is a secrets engine enabled at Terraform/AWS. So any other credentials that I need to access regarding the Terraform infrastructure, I will access from this path specifically. Now, I'm going to run a make command just to show the sequence of commands that you would run. But in order to retrieve the information from Vault, so I need an access key and I need a secret key to put into Terraform to run and create this infrastructure, I'll do a Vault read Terraform/AWS creds HashiCups. HashiCups is my role, right? So the role itself only has read access. It can only grab information and grab the access key. So what you're seeing is that this is a unique access key. And if you check Vault, Vault does something called leasing. So it creates a lease for the specific access key, and this is one such lease, right? Now, if I run this command again, I run a read command once more, it's going to issue a new access key and secret access key, and you'll notice the two are different. And if I check my leases, I see the second lease. So what I'll do is I'll copy this access key and put it into Terraform and run it. Now, I've already done this. I don't want to show my keys online, so I'll show you a little bit of what it looks like. But some of the variables that I've configured as part of my namespace, if you're not familiar with Terraform Cloud, that's all right. But some of the configuration that I've added, this was a previous set of access keys and secret access keys, as well as the session token that's issued from Vault that I added to Terraform to run. So it's run, Terraform has run, it's created the ECS cluster and the database, which is great. So I have all this infrastructure available to me now. So you'll notice this is the ECS cluster right here. But now that we have the database, we have usernames and passwords, right? We have people who need to access that database either to configure information, or we have services that need to read information. So Jeff, how exactly do we configure this database to issue usernames and passwords that rotate, let's say, every day?
Sure. So one of the secrets engines that I talked about before is what we call the database secrets engine, which basically works with most SQL services that are out there, or most SQL databases that are out there, and allows you to dynamically generate credentials, unique usernames and password sets with certain levels of permission within databases, and then have those revoked when the time is correct. And the way that this generally works is most secrets engines have kind of configuration for that instance of it. That might be, for instance, the credentials that Vault is using to then reach out to a SQL database and make that call. And then we have roles, which are things that can be kind of individually authorized for a requester in Vault. And that role stores information about the particular things we want to do. So as an example, a role has the things like what are the creation statements that should be run? What are the SQL statements that we want to run when we want to create a new user? And based on what's in there, that creation statement might say grant, just select on a particular set of tables, or it might say grant insert and delete and select on tables. So that's where we sort of are able to configure what is happening and what the user is allowed to do in the database.
All right. So let's take a look at what this configuration looks like for Vault, right? So in Vault, I've done something very similar. I've enabled a secrets engine for the database, in this case PostgreSQL, and I have it mounted at HashiCorp/database. This is all parameterized, so that way I can change it as much as I need to. But in terms of the connection itself, the important thing to recognize is that you have to specify a database connection URL. This is fairly long, but the connection URL for PostgreSQL includes the Postgres username, password, the address, in this case it's my RDS managed database address, as well as the port and the specific database that I want to use. So you need to configure the connection URL. This allows Vault to connect to the database and therefore issue SQL statements to get usernames, passwords, etc. created. Something that is also important to recognize is that when you create a backend role, this is what Jeff was mentioning before, if you have a role, you need to associate a statement with it. This statement is a database statement, and it's allowing me to create a database role for the username, password, and set an expiration. So this allows Vault to set an expiration for the specific user that is being created. You'll notice the permission here is granting select on all tables. This is a read-only command. This is because this particular database role only reads from the database. I don't want it to configure anything. I don't want it to add anything to the database. I just want it to read, because this is my service. Remember before I talked about product API connecting to the database. It's a read-only operation. It doesn't want to do any writes. So from a privileged view, I'm only allowing it to read. The other important thing you can configure is the revocation statement, which allows it to remove the specific username that's in the database. Now, depending on the database that you have, these statements will change, and you can also alter them for any kind of important workflow that you want to support. The other thing that I have added is that, again, Vault policy appears again. This is a policy for the product API. If the product API has an identity, needs to access Vault, it only reads the credentials from this path. It's not allowed to access the AWS credentials. It's not allowed to access anything else. It's only allowed to access these read-only database credentials. So when I examine my secrets engines once again, I'll give you a look. I've created yet another database secrets engine here. It's at, again, HashiCorp/database. And if I run this command manually, this is not something that you will necessarily do manually. This is something that the product API, the service itself, will do. It will, you don't do this, but, and I'll show a little bit about how this does this automatically. But when I read the database credentials for product, you'll notice that it issues a username. This username includes the role, product, right? And when I look at the leasing, like whether or not it's been issued, again, I get a sense of who has it and whether or not it's been issued, right? So we've set up some configurations so that at least the product API could access the database now manually, right? I could copy this username, paste it to product API, and say, hey, use it to access the database. And once it, let's say, rotates, every couple days, I could copy and paste and maybe manually add it to the product API. Not terribly elegant, but we'll move on to a solution for that later. However, there's an important problem that I have, and there's no data in my database. There's nothing in it. And as a result, my application is, well, it's not going to do much without data. So I need a way to securely access my database and load data into it as perhaps an application developer. Jeff, what would solve that problem?
So what we're going to show in our demo is we're going to show using Boundary to control access to the database. And we're going to tie it together with what you just saw with the Vault rules in just a moment. And so I'm going to talk a little bit about what Boundary is. So Boundary is a software-defined perimeter product, SDP. And Boundary is focused on managing sessions that are being made from a user to machines. And so the way that this can work, so Boundary is able to take a network connection that's been authorized, authenticated, send it to an endpoint that's on some other kind of network, hence the name Boundary. And the way this is going to work is that the user is going to request database access from Boundary. So they're going to be authenticated to Boundary. They're going to have a set of permissions within Boundary that dictate what they can connect to. Boundary is going to request database access, the user is going to request database access to Boundary. Boundary is going to be configured, and I'll talk about it in just a moment, kind of what this looks like, what these resources are. Boundary will be configured to talk to Vault and ask for the database credentials. Vault is going to create those credentials, return them to Boundary. And then Boundary is going to broker them back to the user, and so they're going to be dynamically generated for that session. And so before we sort of get into Rosemary's going to show the Terraform for all that, which is really, really cool. I'm just going to explain what you're about to see. So within Boundary, there are a number of resources. We start out with scopes. Scopes are just containers. So we have scopes that contain IAM information like users, accounts, and groups and roles and things like that. And then we have projects that sit under these, under the organizations. The projects have your infrastructure information. So those are the things that define what are the hosts you can connect to. And so we have this separated out a bit so that it can better match organizational structures that exist, where often you might have multiple projects, but within a business unit that might map to an organization or within the entire organization itself. And so those are kind of the basic things you'll see with scopes. And then within scopes on the project side, you're going to see host catalogs. Host catalogs contain hosts. Hosts are the things that you can connect to. You'll also see host sets, which are groups of hosts that have identical sort of access control parameters. And then finally, you're going to see a credential store. So credential store is something that can get credentials for a session. One of the ones that we're going to be enabling is a Vault credential store. And so that allows you to connect to Vault, get secrets that are related to a session, and make use of it.
All right. So that's a lot of words. So let's actually see what this looks like. Imagine that I have a business unit called HashiCups. This is my coffee ordering system, right? So I have HashiCups. HashiCups is available as an organization in Boundary. Now, if I had other business units, maybe there's accounting, right? Or maybe there's a coffee bean business unit, I would add that to my organization as well. In this case, I just have the HashiCups, right? I have two sets of users. I have an operations team, and I have a development team. My operations team maybe only needs access to certain kind of infrastructure, and that might be EC2 instances, right? You only trust certain people to go in and do any kind of break glass changes and manual changes to some EC2 instances or other databases. And in which case, I've grouped that under core infrastructure. So when you take a look at Boundary, there's a concept called a project, and you can group sets of infrastructure under that project. In this case, I have grouped a ECS node target. And so this allows me to group a set of ECS nodes that I can SSH into. There's nothing in that right now. We'll configure it in a second. The other access that I have as an operations team member is that I have access to the product's infrastructure, right? This is just, again, for any break glass scenarios or any kind of debugging that might need to happen. And in this case, I have access to the PostgreSQL database that we had been using before. We remember we issued usernames and database passwords for that same database. Well, it's already been onboarded into Boundary for me. Now, this is me as an operations team member, but what if I'm a development team member? If I'm a development team member, I have access to just the product's infrastructure. You'll notice core infrastructure, if I click on it, I've switched to the developer view. I don't have access to anything, really. I know that it exists, but I don't have access to what targets are available to me. I can't access it, right? So from an authentication view, Boundary will not let me access those ECS nodes that I had added. But as a developer, I do have access to the database for some reason or another because, hey, maybe I need to configure something. Like right now, I need to load some data into it. So what I'll have access to is the target endpoint for Postgres. So this is all in the Boundary UI. All right. So remember before I talked about me as a developer needing to load some data into the database, but I don't really care about getting a username or a password. I just want to magically authenticate to Boundary, and then Boundary should just help me log into the database. I don't need any information about the username and password explicitly. So how would I exactly do that?
So we're going to talk about Vault credential brokering. And we showed this slide before, but I'm just going to talk through it again because now that you've sort of seen what this looks like and kind of what the UI is showing you, what we're going to do is Boundary is going to say, hey, I know that this target is mapping this set of hosts to this credential store and to a credential library in that credential store that is mapped to the Vault database secrets engine role. And so when you make that connection and you say, I want to make a connection to the database, Boundary is going to take care of acquiring that credential for you. It's going to return it to the user. The user can make use of it directly. We also have some helpers that allow it to be kind of easier to automatically consume that. And then what Boundary will do is at the end, it's going to go to Vault. And even though Vault would have a lease that it's tracking, would eventually say, like, I'm going to revoke this, once that expires, Boundary is going to go and say, actually, we're done. Like, just go and revoke it right now.
So the first thing I'm going to show is how I configure this, right? This is a operator configuring this, so that way a developer doesn't have to worry about it. So we're going to show the operator configuration first. The first thing that you need to do is configure Vault to issue credentials to Boundary, right? And it's very similar to how we configured it before. How we configured it before was that we said, hey, if you want to get a set of database credentials, create a credentials path and add a role. So in this case, I have a role that says I need to access the database username and password. So it's a very, again, long configuration, but the big difference between this role and the one you saw with the product, right, with product API, is that you'll notice I have write access. I have create, read, update, delete. So Boundary, any human user going through Boundary has a higher level of access to the database than the service, right? The service only needs to read, so I don't want to give the service itself write access. So in this case, human users do need read and write access, so I'll give that. And the main difference as well is that you'll also need to issue a Vault token for Boundary. So I'm using Terraform to issue this just to make it easier to pass to Boundary. The reason why is that Boundary does need to have a Vault token in order to authenticate to Vault and retrieve credentials from that path. So all of this is parameterized, which makes it a little bit tricky, but walking through a little bit, remember that our credentials path for Boundary to get database credentials is creds Boundary, and I pass that credentials path here into the Boundary credential library resource. So I create something called a credential library, and what that will do is set the exact path that needs to be accessed by Boundary to retrieve specific database credentials. And it's a get method, it's a read method, there's nothing fancy about this particular retrieval. You can set different kinds if you need to, but it is a Vault API, right? And more importantly, I was able to pass in that token as well as the address to the credential store. What this looks like in the Boundary UI is if I examine this as Jeff, the operator, what I'll notice is that I've set up a target, the products database, and I set something called a credential source. And the credential source points to an HTTP Vault credential library for the database. So once I've configured this, it automatically sets up the information that I need to pass to Boundary and Boundary will access Vault at this particular path. And so the great part about this is that as a developer, I don't really need to see this portion of this, right? It's already pre-configured. So Jeff, what happens as a developer authenticates to Boundary and needs to access the database?
Yeah, so what happens is the user goes to Boundary, and Boundary looks at their token, and it looks at their it looks at all of the roles in Boundary's RBAC system that they are assigned to. It looks at the grants that are supplied by those roles, and then it says, either you're not authorized to actually make a connection, or in our case, it'll say you're authorized to make a connection. And it generates a TLS stack that's unique for that particular session between the user and one of the Boundary workers. So everything that you do, even if you're connecting to localhost, even if you think that that it looks like it's unencrypted, it's actually always encrypted going to and from the user and the Boundary worker. It will then generate a session authorization token. That session authorization token contains that information and also allows essentially the user client, so either the Boundary desktop UI or the Boundary CLI, to make that connection to the worker, present its credentials, and have that connection proxied all the way to the database. So that's what Boundary's going to Boundary's going to show. That's what Rosemary's going to show in just a moment with Boundary.
All right. So first thing I'm going to do is imagine I'm Rosemary, the application developer. I'm going to authenticate to Boundary. So the command is Boundary, let's see, it's going to authenticate with Rosemary and Rosemary's password, so Boundary authenticate password. And Boundary comes back with the token. Since I'm using my machine, it does have a keyring, so it's storing the token in the keyring. I don't have to authenticate all the time, but throughout this demo, you may see me re-authenticating on occasion, just so that I can run the commands without worrying about authentication to Boundary repeatedly. So in this case, I'm authenticating as the developer. And now what I'll do is I'll show you the authorized session, which is a little bit of what Jeff mentioned. So remember, it's a two-step process. There's the authorization piece, and then there's the actual connection piece. And what you can do with the authorization piece is that Boundary will authorize you to retrieve Vault credentials, right? But you can choose to use these manually. So what I'm running is the command of Boundary authorize session, so that I could just manually retrieve the Vault credentials for the database and just use them for debugging or other purposes, right? So what I've done is Boundary targets authorized session. When you use targets, what you have to do is set the target ID. This target ID matches the database. Let's pull up Boundary and double check that it matches the database, just in case. So it does that in this database, right, TR2, same ID. You'll need to use that ID to allow you to authorize the credentials. I've written it out to a JSON file, and you'll notice, hey, it's a username, and it has the role in it specific to Boundary. And what I can do is I can use these credentials for manually accessing the database if I really need to, right? Again, just for a break glass scenario or some other purpose if you have a client that you need to use. The other thing, again, we print out the leases. You'll notice that it's issued the lease.
Can I jump in for 1 second?
Yeah.
So while she's doing that, I just wanted to point out, you might be asking yourself, well, if I can just get the credentials from Boundary, from Vault, and just do it that way, why don't I just connect directly? So remember that we have this multi-tiered infrastructure where you don't necessarily have access to the private network. So Boundary is both acting as sort of the gateway between those boundaries. And it's also, there are layers of security that you can add on. So for instance, if your database is configured to only accept connections from Boundary workers, then even if you get access to the private network, even if you have, if you don't have access to the private network, if you have access to the private network, even if you have the credentials, you can't actually connect to the database because the database at a network level is told only accept connections from Boundary workers. And there are other things that we can layer on, and as the product moves forward, there's going to be more and more stuff that we layer on to that security as well to make that story even better. But that's why if you're thinking, oh, if I can just get the credentials through Boundary, what do I need Boundary for? It's because a big part of sort of the defense in depth story is making sure that it's not just that Boundary allows you to get into the network, it's that you can only get into the network through Boundary.
All right, so with that in mind, I've already run this configuration just to quickly configure the database. I already loaded the data. But the same command applies, right? Similar command applies. Boundary connect Postgres, and I specify the target ID, which is, in this case, the target for the database. I also can specify the database name, in this case, products. Remember, I had that. I can also run the SQL script that loads all the information as well. And what's kind of cool about this is that, as part of the workflow, we talked about, the fact that someone could, they have the leases, right? So Vault will issue sort of a lease to use these credentials for some period of time. You'll notice two, right? The first one was the one that I manually retrieved via Boundary, and the second is the one that was actually issued when I use Postgres, right? So what I'll do is if I go to sessions, you'll notice there's still a session that's pending. And what I can do is as an operations team or security team, I'll just cancel that for now because maybe we just don't need access to it anymore. And in this process, right, what this will do is, remember Jeff mentioned that Boundary will ask Vault to revoke. So Boundary will cancel the session, but then ask Vault to revoke the credentials. Vault revokes asynchronously, so it may take a little bit of time, but what you'll notice is that Vault will eventually revoke the second set of credentials here. It does take a little bit of time just because it doesn't want to revoke it immediately. It wants to gracefully terminate the network connection.
And Boundary does that too. When you ask it to cancel a session, then we immediately cancel the network part of it. But we want to make sure that we aren't blocked on Vault in case for some reason Vault's unavailable. And so the job that Boundary uses to actually ask Vault to revoke is also an asynchronous job. And so we may need to come back to this command, but at some point if we come back to it, it will be gone.
Yeah. All right. So we've gone through this whole, thing of a developer accessing the database and trying to get more information. So, well, what's next, right? What if an operator needs to connect to those EC2 instances? I mean, SSHing is tricky to manage, so how would I do that?
Yeah, so right now we have a notion of targets, and targets, besides just mapping things like credential sources and host sources together, they also have a protocol attached to them. And so we have a TCP target right now. And we focused on that first because it means that basically any TCP connection that you can make can be proxied through Boundary and have that authentication authorization layered on top. And so within the target configuration, I don't know if you noticed before, or Rosemary might show it again, but you can have a time box for your sessions. You can also have a connection count. So you can say, any session is allowed to make 2 connections. So for Postgres, for instance, it makes 1 connection to discover authentication methods and information, and then it makes a second connection with the actual value. But you can say, you know what, this session is never allowed to make more than those 2. And so there are some flexible controls that allow you to kind of fine-grain, tamp down on like what's able to happen over a session. But so for SSH, because it's TCP, then we can also send that through Boundary as well.
All right. So what we're going to do is a little bit different, but we're going to reuse a few things, right? So remember I showed the AWS Secrets Engine giving me AWS credentials for Terraform to run. Well, what we're going to do is we're going to configure the same AWS Secrets Engine to give credentials to Boundary for a very neat feature called Dynamic Host Catalog, right? So it's the ability to auto-discover EC2 instances if we need it. Especially in the case of ECS clusters, right? You automatically use metadata to register a container instance to a cluster. Similar approach. So what we're going to do is we're going to start with a configuration, once again in Vault, to allow Boundary to describe instances. So you'll notice that this is a little bit of a different configuration in the AWS Secrets Engine in that I set the policy document, the IAM policy document for AWS more explicitly here, and it has access to describe the instances. But it also has a couple additional access requirements as well, just because this is issuing an access key and a secret access key. So that's one thing you can configure. I've already started configuring a few things. The first is that I've now authenticated as Jeff, because as Rosemary, the developer, I don't have access to configure this host catalog. Remember, EC2 instances related to the ECS cluster are only allowed to be accessed by the operations team. So as Rosemary, the developer, I can't access it. So I'm going to log in as Jeff.
It's clearly bad security. I should not have given Rosemary my password.
Yes, I'm going to use Jeff's password. But the important note is that I'm adding a host catalog. So remember before I showed the Postgres target, this is very similar in that this is the ECS nodes target, right? So I'm adding a host catalog with a plugin. This plugin is the AWS plugin, and what this will do is automatically discover instances with specific filters. I also have to pass the access key and the secret access key, which, hey, I generated with Vault previously, so I showed you the Terraform for that, and I'm passing that in. And then I create something called a host set. So this is a set of hosts, well named. One of the filters that I've set is the cluster HashiCorps. This is the name of my ECS cluster. So it's a great place for me to use to tag it and then also filter for those specific instances. I only have one instance for now, but it will discover as I add more instances or register more instances. So it's using that tag. I've added the host set to the target, to the boundary target. You'll notice that it tells me, hey, you already have a target created, and it's also using default port 22. The other thing to note is that there's an unlimited session connection limit. So there's a number of things that anybody can do to connect to it. Jeff, could you explain a little bit more about session connections?
Sure. So I talked before about how for Postgres, generally on like PSQL, you'll need 2 connections to be made. And so what we do is we create a session. And then within that session, you have some either unlimited or limited number of connections you can have. But what we also do is we constrain it to an individual client. So the first time that a session is activated, that goes from a pending state to an active state, the client supplies a trust on first use token. And that token must remain consistent. And so if that client wants to make more connections, and that client is usually like the boundary service, the boundary CLI that's running on your machine, that's opening a listening port. If you make another connection through that port, then your client will supply that tofu token in with that connection that makes the worker, and therefore it will be allowed. But someone else can't take that session authorization token and reuse it because you've already done it and it'll be tied to your tofu token. Yep. So we make sure that, that even though a session can have multiple connections, that we have positive control over where those connections are being made.
Yep. All right, so what I'm doing is I'm going to just list some of the hosts. It may not be, all right, well, let's take a look. But sometimes it may or may not discover it, but we'll see if it works today. Otherwise, we'll move that. Live demo. OK, so let's go to host catalog. So what you'll actually see if you go into the UI is that you'll notice that there's a host catalog here, and the host has been added, right? So this is the host for EC2. There are 2 of them right now, so we'll see how it goes. But let me just SSH in. So I'm SSHing in as Jeff, right? So Jeff, the operator, needs to SSH to this EC2 instance for some reason or another. All right. So we'll re-authenticate as Jeff. And what this will do is connect me to the EC2 container instance, right? So I'll connect in, and you'll notice that I can connect to my ECS container instance, right? This is running EC2. There are a couple of things running on here. And previously, I found some interesting things that were going on. At one point or another, my product API wasn't working, so I called Jeff and I said, hey, my product API is not working, it's not coming up, something is wrong. Jeff is able to go in here and take a look and examine why it's not working, right? And so it's pretty powerful in that, well, he can go in and take a look and debug and find out what he needs to do. Now, let's say he's done, or a security team says, hey, please, you're done with this, right? Security team can, again, cancel the session. And once they cancel the session, you'll notice that Boundary will close that connection. So it's a way for you to control those sessions. It's something that Jeff mentioned before. All right, so Jeff, what do we have next? I think we talked about enhancing security through human users. We talked about enhancing security through machine authentication using Vault. So that's what we showed with the database credentials and the various secrets engines. But we have something else that's important. We have a couple of services, right? And these services are APIs. We need some help with API authorization. So how do you control identity access between services? And that's where we'll talk a little bit about HashiCorp Console and the Service Mesh. So HashiCorp Console offers Service Mesh capabilities. It supports Envoy Proxy. What you're doing is adding a layer of service identity that allows you to manage traffic between the services. So what we showed right now was that we showed, OK, a human can access the database, human can access EC2 instance, Vault can issue credentials and therefore use machine identities to identify who can access what. But now, well, we need a way to allow services to understand how or whether or not they can communicate with each other. And so what we're going to do to add this layer of identity is add console on ECS. So console on ECS runs using a Terraform module. The module is available if you're interested. It is, let's see, it's on the Terraform registry. But if you take a look, there's a couple of components that you'll need. I'm using HCP console, which is the managed console. And it is offering some additional layer of security. So you have to do something, you have to deploy something called the ACL controller. Console has a concept called ACLs, which allows and controls access to parts of the console API for services, right? You want your services to only
access certain parts of the console API after all. So you have to deploy this controller, which issues tokens and allows certain services to register or certain services not to register. So that's one part of the module that you'll need. The second important part of the module that you'll also need is this mesh task. So when you deploy a task on a task or service onto ECS, you do need to add information about the task definition, its capabilities, volumes, et cetera. What I've done is I've used this module, and what it will do is inject the sidecar, the Envoy proxy, as well as the console client for me, right? So it's run both on Fargate and EC2. This case, I'll show you the product API, which is using the EC2 launch type, but the same goes for Fargate as well. So if you check out this repository, which I'll link to at the end, it's a front end and public API uses the same exact thing. Something that's a little bit different and pretty interesting is that remember I talked about product API needing database credentials, which we configured in Vault. Well, we did this automatically now. I added a volume to my task definition, and I'm using something called Vault Agent. Vault Agent will handle the authentication to Vault and then retrieve the credentials that you need and render it to a file. So what I've done actually is set up Vault Agent using, to authenticate to Vault using an IAM role. So I set up an IAM role, and this is the task role, actually. So the task role, it will authenticate to Vault and then give me the database credentials and inject it, right? So it injects it first, and then I can start up my application. So you'll notice this depends on, and for the most part, I don't see anything about the proxy. I don't see anything about the console client. But when you examine this in ECS and you examine the service that's running, so we can take a look at this one, for example. We'll take a look at the tasks. The tasks have a number of containers that have run or already run. One of them, let's say, has already initialized the tokens, retrieved information from console, gotten the right information, as well as the sidecar proxy. This is Envoy, and then the console client. Now, why is this important? Well, when you have a service catalog of all your services between on-prem and AWS, you have the ability to get this consolidated view of what services you have. Remember, system of engagement, not necessarily a system of record anymore. So here I'm able to say, here's a front-end app, here's a product API, here's a public API. With the proxies, what I'm able to do is do some network policy. So I'm able to control which services access each other using some authorization. So right now, if I check out the public API, I'll show you right now what's going on. But if you check out my poor application, it's not working. And let's take a look at why. Well, if I examine my GraphQL application, front end can't connect to it. I'm not allowing that, right? If I look at something called intentions, this controls the policies between services and the authorization between the services. I have nothing for front end. So what I'll do quickly is create a rule to allow front end to public. And what this does is enable the traffic between the two using filters. So if I refresh this, all right, so now you have a front-end application accessing the public, and I'll show you that this is connected indeed. There are a lot of other things you can do, right? You can do traffic shaping. If you wanted to do Canary, you wanted to do more fine-grained control over traffic shaping from an application perspective, you can do that. But if you're trying to just control this from a service identity and authorization view, this is usually the view that you would be interested in. So once this is connected up, if I refresh, let's hope this works, I can now once again, order my cups accordingly. So I can go and pick anything out of the menu, I can scroll, and if let's say something is happening, maybe I want to deploy a new version, I can also use the same approach, the service mesh capabilities here to also control traffic between multiple versions. I can say, okay, turn off traffic to this application or to this identity specifically. All right, I think we're at the end of that. What happens if we want to learn more?
I've got a lot of resources. You can check out this demo itself at that top link. That's Rosemary's GitHub name. So the whole thing is available to check out. If you want to learn more about Boundary, boundaryproject.io, vaultproject.io for Vault, and those are some particular links to it. Console.io, and finally we have on learn.hashicorp.com, we have a whole set of, for each of the products, we have a bunch of different learn guides that walk you through doing very common things and kind of take you step by step. So lots of resources available. We also have a discourse community, so you can interact with other users and with developers directly, ask questions, help out other users, get answers, et cetera. So thank you very, very much. Rosemary put together an awesome demo, and thanks for coming and listening to us talk at you for a while. We have some time for Q&A. So if anyone has questions, we are more than happy to answer.